Alright, so in this problem, I have 3 to the power of x is equal to 80. So, I want to find the value of x here. So for my solution, I first start with 3 to the power of x is equal to 80. And now, I'm going to take the log on both sides. So I get log 3 to the power of x is equal to log 80. Now, we want to find a way to, we want to find the value of x, right? And to get x, it's hard to do it when it's in exponent form. So we want to find a way to bring x down to make it a real term. And to do that, there is an important property of logarithms that states that if there's something in the form log a to the power b, I can move this x1b to the front. So this is going to equal b times log a. So in this case, I have log 3 to the power of x, and I can move x to the front. So now I have x times log 3 is equal to log 80. Now from here, I'm going to rewrite 80 here as 8 times 10. And if I have something in the form log a times b, this is equal to log a plus log b. And this is another one of the logarithmic properties. There is also log a over b, and if I have something in this form, this is the same thing as log a minus log b. So now going back to the problem, we have log 8 times 10, and we can use this property. So we can think of 8 as a and 10 as b. So this is going to equal x log 3 is equal to log of 8 plus log of 10. Now, if you guys already didn't know, log 10 is simply equal to 1. So I get x times log 3 is equal to log 8 plus log 10. Or sorry, just 1. And now remember, we want to isolate x, so the only thing left to do is to get rid of this log 3 by dividing both sides by log 3. So then this cancel out, and I get x is equal to log 8 plus 1 over log 3. Now, log 8 is equal to 0.90309, and log 3 is equal to 0.4771. So this is going to equal 0.90309 plus 1 over 0.4771. And this is equal to 1.90309 over 0.4771. Now 1.90309 over 0.4771 is equal to 3.9889. So x is equal to 3.9889. Now, the only thing left to do is to check if my solution here is correct. So the original equation was right here, 3 to the power of x is equal to 80. And my solution is x is equal to 3.9889. So if I plug this in for x into my original equation, I get 3 to the power of 3.9889 is equal to 80. Now 3.9889 is really close to 4, right? So let's first find the value of 3 to the power of 4. 3 to the power of 4 is the same thing as 3 times 3 times 3 times 3, which is the same thing as 9 times 9, which is equal to 81. Now 3.9889 is a little less than 4, meaning we can estimate that it's going to be around 1 less than 81. So it's safe to say that 3 to the power of 3.9889 is close to the value of 80. Alright, so in this video, I'm going to solve the equation x to the power of x to the power of 16 is equal to 2 to the power of 2 to the power of 2. So to solve this, I'm going to first rewrite 2 to the power of 2 to the power of 2 as 2 to the power of 4, because 2 squared is 4, and 2 to the power of 4 is 16. So this is all equal to 16. Now from here, I'm going to write 16 as the 16th root of 16 to the power of 16. And this is the same thing as the 16th root of 16 to the power of the 16th root of 16, because 16 is the same thing as the 16th root to the power of 16 to the power of 16. Now, notice how this is in the form x to the power of x to the power of 16 is equal to the 16th power of 16 to the power of the 16th power of 16 to the power of 16, meaning x is equal to the 16th root of 16. Now, I can simplify this a little bit. The 16th root of 16 is the same thing as 16 to the power of 1 over 16. And 16 is also the same thing as 2 to the power of 4. So I get 2 to the power of 4 over 16, which is equal to 2 to the power of 1 over 4, which is equal to the 4th root of 2. So this is my answer.